Hello, I'm Andrew Wichmann. I work for an organization called Johns Hopkins Technology Ventures, which is an organization inside of Johns Hopkins University where our mission is to translate technology that comes out of Johns Hopkins however we can. And increasingly, for someone like me who works in digital technologies, open source is a fundamental way of doing that. Certainly, it's the fundamental way that the researchers I work with, like Peter Shea, who's still here, disseminate their research. So it kind of comes with the territory in academia. I didn't send Miguel a bio, so here's what I am. So like I said, I do IP work and I negotiate licenses on behalf of the university to the outside world, whether it's NVIDIA or your startup company. That's me on the other side. I work exclusively in digital technology, which basically means software, but also data, video content, what you're doing. Before I came to Johns Hopkins, I was a lawyer for 5 years in private practice, doing a lot of IP and business work, basically representing startups. And then I worked in one for 5 years before that. So that's my background. I'm not a machine learning researcher. I do robotics in my day job, but I do work with the people who do it all the time, and I think a lot about how we could do better in helping to translate these technologies. So my agenda, I'm not going to be able to get through all of this. I don't think this is a pretty broad topic. Commercial open source software can do a lot of different things. So if you all have specific questions while I'm talking, I don't prefer this wouldn't be a lecture, but whatever y'all want. So please interrupt me if there's something interesting you want to talk about. So the motivation, this is from the institution's perspective. Most of you all work in an institution, meaning a research lab or academia, or in government or for a foundation or something of that nature.
Yeah, just double check it.
All of these organizations tend to have the same mission, which is to disseminate knowledge and translate technology. That's usually pretty clear, the differences between technology and knowledge in some fields. Like the molecules embodied in a compound, that's a technology, whereas the article explaining why it works and what it does and how it is valuable is the scholarship. With software, they're merged, at least in the code artifact. If your primary research artifact is code, then that is oftentimes both your scholarship and the technology itself. That code can go and do things in the world in a way that normal publication cannot. So that makes things a little bit more complicated. But fundamentally, we're still trying to provide access via publication to that code, which open source does. And we're still trying to make that code into a technology that does something in the world, which to me requires sustainability. Sustainability is a big word that can mean a lot of different things, but basically it means, to me, there needs to be some sort of model for funding the continued support, administration, management, deployment of that code if it's going to live and do anything useful. And I'll hammer that point in a little while here. So commercial open source, a variant of open source practices, provides sustainability if done successfully. And the result of that is people like me should be supporting commercial open source software as a mechanism to do our jobs. You've probably heard, perhaps you all heard this phrase, I don't know how widely these things get in the open source world, but historically there's a saying that open source is free as in speech, not as in beer. Someone clever, a guy named Michael Nash, wrote a blog post a while back saying software is really free as in puppy. And he analogized his project, his software project, to the new puppy he had just got. In fact, it was 2 puppies. This isn't the actual dog, I just like greyhounds. But his dogs are German shepherds. But his point was that he thought a lot, planned a lot, got the exact dogs that he wanted, but it was still like 7 years of hard work just to get those dogs behaving correctly. And the blog post just takes you through all of the terror that these dogs wrecked out his life. And his point was, of course, that releasing your code open source is just the beginning. That doesn't really successfully do anything other than communicate what that code says. If you're going to maintain it and have other people using it and come to rely upon it, you have to do a lot of other things, and those things never stop. until the code dies or the dog dies. You always got to take care of the dog. You have to raise it correctly. A related concept that comes up all the time in my life is that when you're dealing with code built in academia that are built on a grant cycle, that grant cycle always ends. And so even, no matter how well funded your lab is, no matter how much everyone agrees this is a great tool, unless you're finding someone to pay for it, or you find some endowment or something to support it indefinitely, almost all other grant funding goes away, and then you have to figure out how to maintain the project, at least so long as it is in academia. This is a diagram from a big project. It's not related to robotics, I'm sorry, but it is scientific software, research software that came out of the university. These are all the deployments of it at some point in time, I guess a couple of years ago. None of those are being funded, So there's one grant to pay for this software that's doing a lot of work for a lot of different researchers, but none of that is coming back to continue to fund the project that is providing that service. Quick note on opportunities, probably also not lost on this group, but the people like me and offices like mine are built on a proprietary mindset. Historically, what we did is file patents on things that we were disclosed to us, and then we licensed those patents. And if there was code involved, that code was generally closed source proprietary code. And the whole mechanism was to maximize your right to exclude over whatever you could of this research to provide the greatest benefit to whoever is going to take it on the outside world and do something good with it. For the reasons you all have probably experienced over the last few days, open source software sometimes does that a lot better for digital technologies than proprietary approaches. And over the last roughly 10 years or so, you've seen markets react to that, and the valuation of companies leveraging open source software increased dramatically. So this was a recent article, came out earlier this spring, a Harvard Business School study, basically said, like, if you got rid of open source software and asked all these companies that are relying on it to build what they're using from scratch, it would cost some 8.8 trillion, ungodly amount of money, $8.8 trillion. So there's a massive benefit provided that's a public good to companies relying on open source software. And so value is being transferred, the technology is being transferred. How do we connect that value back to the technologies themselves so that they stay alive, so that your puppy doesn't die? These are some widely cited graphics from a venture capital firm called OSS Capital that specializes in seed level investment, basically in open source companies. They just to illustrate the rise and increasing rate of growth of open source based software companies versus their closed source alternatives. I'm sure you recognize most of those companies. And then similarly, another graph from the same VC firm talking about just the types of VC that are investing in open source companies. So OSS Capital is the largest because that's all they do, but lots of other very prominent open source, A16Z, I think Google Ventures is in here. I mean, lots of large, Sequoia, large companies, anyone investing in tech is very aware of the potential for open source startups. So what's difficult is under the prevailing kind of base mindset of technology transfer, like I said, the idea is we just need to maximize the IP position in this research and then let the outside company pay for that exclusivity and then go do what they want to do. It's a very simple kind of calculus. The software, not only is that harder to do because software changes all the time and it's not really a thing. As we talked, someone mentioned the software factory idea. You're not delivering a result, you're delivering a continuous set of services to someone. Because of the nature of software, and also because of the complexity of software, I would say, that's difficult to do in the traditional sense of the word. Offices like mine do much better with biotech than we do with code and those mechanisms. So you have to, if you're going to work in the open source world, you have to think about it a little bit more ahead of time. You have to think about the business implications a little bit more ahead of time. There's more planning. in entrepreneurial thinking to successfully translating open source code than there is in traditional technology transfer. So what I wanted to do is just highlight what are the common models at a high level, and stop me if like things, I'm saying words that don't make a difference to you, but just because I think like if you're thinking about if you're in academia or you're in some research capacity and you're building research software and it's doing something really cool, if you want that to keep going, you got to start thinking about who's going to pay for it and how, and whether you're going to run that company or someone else. A lot of the things you need to put in place need to happen while you're building it and while you're building a community around it, if that's the route that you're going. And that just requires a level of business thinking and planning that is not, not commonly what goes on within research institutions. So the first basic model, and Red Hat is, the poster child for this, is what you usually hear as a services and support. So the reason it's called that is that you're not selling software, you're selling services and support. You have an open source project that's wildly successful. You release that under an open source license. So I distinguish permissive and reciprocal. Does everyone here know what that means? Should I explain that? So basically, without going into the weeds, there's two large categories of open source licenses. There's permissive, which are what they sound like. Meaning, if I permissively license my code, anyone can largely do whatever they want for whatever purpose, without any real negative commercial implications to how they use that code. A reciprocal license generally means that if I make an open source project and I release it under a reciprocal license, and then someone else takes that project and improves upon it or wants to make a commercial product out of it, their improvements must also be made under an open source license. That must also be released. And so the idea is you are building in a mechanism to continue to build the open source project over time by the original license that you released it under. That is good for healthy open source ecosystem. That is not always good, at least in the perception of the commercializing entities, because they have to then make public all the proprietary special things that they can use to make products. Yes.
You said we can ask questions.
Of course, yes, please. I don't like to talk at like.
Experience with setting boundaries in these reciprocal libraries. So, for example, I think as soon as the stuff is compiled into a binary, and you just call that binary, and don't use the API or the software as open source, then things change, for example.
So there are the major family of reciprocal licenses, or sometimes they'll be called copyleft licenses, is the GNU family of licenses. There are distinctions among different types of those, which I think we want to take offline, but that I think are getting at what you're talking about, which is that some, if they're attached to a library, if all you're doing is calling that library without through a dynamic linking process, then it's not considered a work that you have to then release as a calling work under the same conditions. You don't have to make public the program that you wrote that's calling that. Use a different flavor of the license. That's not the case, at least according to the publisher's license. There's a lot of wrangling and historical debate about how real those distinctions are or not. But that's what we have to go on because there's very few court cases that prove things. So we can go into that more, but yes, that's a consideration that you take into account when you're picking your license. Which picking a license is one of these fundamental things you need to think about if you're going to be an open source developer and you want your research to be disseminated open source, because they have different implications, which we'll get to. But the idea here is it doesn't really matter what license for this model because you're not selling the code. You're making the code available. You might be also distributing a binary to make it easy on people or whatever, depending on what your product is. But where you're making your dollars is helping people use that, doing integrations, doing implementations that they're not capable of doing, maintaining it, providing updates, providing professional grade updates, all the sort of professional stuff that goes into software delivery. And that's where the money is coming from. Also, big kind of basic distinction. You'll hear this said a lot. Your project is not your product, or your product is not your project. when you're in academia and when you're doing research, you're always got a project. You never have a product, at least not initially, because that's not the initial motivation. Usually, it's because you want to, do something new because that's what you've spent your whole life studying to be ready to do. It's not to build a commercializable version of that. In open source world, the way you treat your product needs to be distinct from how you treat your project, because you're going to rely on those distinctions in order to incentivize people to give you money for your product, whereas your project is the public thing that you're supposed to see and use and try to understand, have trust in, and all the other good stuff that you get from being an open source person. Second major model, let's see, are we going just over? I know we started late, so. Dual licensing was the second sort of large model. I mean, this was maybe mid 2000s, early 2000s. And the idea here is that, as you were mentioning, certain reciprocal licenses are not desirable for commercializing entities because they don't want to make their improvements open. Or similarly, you can just write a license that just says you can't do one thing or another. Those licenses are not under the historical definition and open source license, but you see them a lot and increasingly with some types of companies where you'll see all the code, but it'll say something like, you can use it except for cloud hosted versions because the product that you're offering is a cloud hosted service and you don't want someone else using it for your service model. But in any case, you're releasing your open source project under some sort of license that has some undesirable characteristic to it for a commercial entity. And then you're releasing the product under a proprietary license like any other normal software transaction. And what that does is it gives you the ability to show your code and call yourself an open source company usually. But what people who are enterprise customers, the people who are going to pay for this are using is a proprietary version that sometimes may be a better version, sometimes it's the exact same version. It doesn't really matter. They're more just paying for the right not to have to deal with this undesirable stuff in the open source project. Went past SaaS for some reason. SaaS is similar to the idea of services support a little bit in the sense of, again, like your open source project can be any sort of open source license, but your product isn't code. It's a hosted service. It's some sort of API or a website or something that's delivering. Like you're going to get the benefits of that code running, but you're not running it yourself. And really, that's done a lot of times because that's more convenient for a large customer. It's easier for them not to have to maintain or install or manage all these different installations across their enterprise. They just provide credentials to their workforce to log in. So again, like you're not getting the code in those cases, you're getting access to a website that's giving you benefits of the code running on servers generally controlled by the provider. So that's that. The third and probably most common thing you'll hear about today is something called Open Core, which has been around since the early aughts, mid aughts, late aughts, 2008 something is the first time I remember hearing about it. And the idea here is it's a little bit of a mix in my mind of some of these preceding models, but the idea is you have a project and then you're selecting features that you want people to pay for and releasing those under different license terms than the overall project. So, and this can be a lot or a little. This is, again, a chart from that same open source capital, OSS capital venture capital firm. But, projects that are almost entirely proprietary and have a very small foundational open code base, things like GitHub are cited as that, whereas Databricks is considered something that is making your you're largely getting the same code as the open source project. There's just maybe like more frequent updates or special plugins or things of that nature, and you can go to one extreme or the other. The kind of fundamental thing is it's all the same project, or it's managed as the same project, rather than sometimes when you have like a dual licensing model, those two code bases can be separate, and one can be more, the commercial one will be like have more bells and whistles or have additional features than the open source project. Another company to highlight here is GitLab. So GitLab, one of the founders of GitLab, is a big advocate of the open core concept. He's built his company on it. He started a venture firm called Open Core Ventures, which is kind of surprised, like focused on starting open core companies. He has a concept he calls, I think it's something called feature-based, something like that, feature-based open core. But the idea is not only are you like when you're picking the features that you want people to pay for, you're thinking about the buyer and buyer's willingness to pay, and being really, really clinical as far as what the buyer is on the enterprise side and what they want, and making everything else open but those things. A lot of literature about it. I would encourage you if you're interested in any of this, read this website. It has a lot of explanations about rationales for why it does this. There's, I guess, a couple other models that I want to highlight that are a little bit different. Open source consortiums exist, exist in academia now. They're complicated to set up, and a lot of universities aren't willing to go through the work to get them in place. But the idea there is largely like there'll be an industry partner like NVIDIA or someone else you've heard from today will want to build some type of usually infrastructural software that's going to benefit them and do good things for the industry. And they'll partner with other industry players or sometimes universities to do that. And they'll do that oftentimes initially in a closed source way. So there'll be a private research consortium, and there'll be some governing documents that say for how long that private part is going to extend. And that work will be done, and the parties to this consortium will all get to share and see all the same information. And in practice, the way the software gets translated is there'll be something in the government's documents or some decision by the consortium that we're going to open source this project. Usually there's something in that says everything I mentioned. And so there's a time limit from when the project gets started to when it gets published open source. And that dark period is when the commercializing entities get a leg up on building a commercialized product. So usually what will happen is before or at the same time that the open source project comes out, you'll see a proprietary version offered by some large company that's really advanced, and they'll be first in the market and have a real deep understanding of this infrastructural technology so that it'll be a successful project. And these things are done, the open source project can be kind of whatever open source license you want, and then the product is typically a closed source product. And then the last example is sort of an open source model. It's another thing you hear a little bit more recently, and is the idea that if you're going to start business around your research, rather than trying to make something that is fundamentally open have closed parts that people are going to pay for, or selling services next to them or something like that, you just start two projects. So you do one thing that'll be complementary to the other, and you sell one, and you build a community, and generally you build it's usually the open source one is something that's more broadly applicable, operating system or some storage technique or something like that. A lot of people will use, and then your commercial thing will be some application related to that, or some valuable feature that maybe is really tailor-made for this open source project. And so the popularity of your open source project is capitalized by all these people already like this open source project, so they're more likely to buy your tooling or whatever it might do. Most big tech companies you can think of, I think NVIDIA, what we heard today about NVIDIA, it's a very similar idea. Their product is compute, or their product is GPUs or something. Their open source project is just to build an environment where those things are going to be optimized. Kubernetes is a classic example. Google just sells cloud because they made a huge open source product out of Kubernetes and everyone likes it, and that just sells more cloud people.